Welcome back with another episode on TryHackMe.com. This is Zahin Nazir, and we are doing dependency management on DevSecOps path. So today we're gonna do from task 5 to task 8. So let's get into it. Task 5, securing internal dependencies. Okay, internal dependencies पे हम आ गए हैं. Internal dependencies or libraries or SDKs that we have developed internally in our organization. As such, we are responsible for all aspects of security of the dependency and its management. क्योंकि ये internal है इसलिए सारी चीज़ें responsibility हमारे ऊपर है. As mentioned before, the primary reason for creating internal dependency is to ensure that we don't have to reinvent the wheel every time we develop an application. That's very true. Internal dependencies allow us to standardize certain processes such as authentication, registration and communication. Authentication की library लिख सकते हैं, कोई registration की या communication की library हम लिख सकते हैं. Security concerns क्या? Internal dependencies have similar security concern as external dependencies, although internal dependencies allow us to standardize a process. If the dependency has a vulnerability, it will affect several different applications in the organization. We therefore have to perform security testing of our dependencies before they are released for use. Okay, तो उसको यूज करने से पहले इसकी सिक्योरिटी टेस्टिंग जो है वो लाजमी है. Alright. Another issue is that internal dependencies can become legacy code incredibly fast. The developer that created and maintained a dependency has started work elsewhere, meaning the dependency no longer receives updates. If such a dependency is used in several applications, it can become an issue if the vulnerability is discovered. This problem can only be made worse if the documentation is not kept up to date, allowing someone new to take responsibility for the dependency. तो अगर कोई लेगेसी कोड जो है उसकी डिपेंडेंसी है और वो डेवलपर छोड़ के चला गया हुआ है, तो अगर उसके अंदर मसला हुआ और वो काफ़ी ज़्यादा एप्लीकेशन में यूज़ हो रही हो, तो दैट कुड बी बिग रीज़न टू वरी अबाउट. और स्पेशली जब डॉक्यूमेंटेशन अर्ली ऑन इतनी ज़्यादा डेवलपर्स नहीं लिखते थे. A unique security concern to internal dependency is storage. We want to ensure that dependency can be accessed by all developers for use but not modification. If all developers can simply modify the dependency, an attacker would simply have to compromise a single developer to compromise several applications. Hence, we need to protect write access to dependencies. In some organizations, even read access is restricted to reduce the attack surface further. तो डिपेंडेंसी की जो स्टोरेज है, जो इंटरनल स्टोरेज है, उसके वो राइट प्रोटेक्ट होनी चाहिए. दैट मीन सिर्फ रीड के लिए एक्सेस आप खोलेंगे, राइट जो है वो उसकी एक्सेस बंद रखेंगे. लेकिन कुछ ऑर्गेनाइजेशन जो है इन चीज़ों को भी बंद रखती हैं. इवन द रीड इज रिस्ट्रिक्टेड देयर. टूल सेट क्या है? एप्लीकेशन एंड टूल्स मस्ट बी यूज टू मैनेज इंटरनल डिपेंडेंसीज इफेक्टिवली. ये मैं पढ़ा था JFrog आर्टिफैक्टरी या एजूर आर्टिफैक्ट्स, वहाँ से हम इंटरनल डिपेंडेंसी कर सकते हैं. These tools would differ based on our needs. If we develop code only in single language such as Python, we could simply host an internal PyPy repository server. This would allow us to upload and install packages similar to how it is performed using pip and internet-facing PyPy repositories. However, if we develop application in a different language, we may adopt to use a dependency manager such as JFrog Artifactory. JFrog Artifactory allows dependencies to be centrally managed and integrated into the DevOps pipeline. As developers are writing code, they can make use of various dependencies hosted on Artifactory. Artifactory also has the ability to manage external dependencies that are used internally as well. It provides a single source for all dependency. This is a very good idea to use Artifactory, okay, for internal and external, for both. While such tools are great to help us manage dependency internally, if they are compromised, it could lead to significant impact. अगर ये tool ही itself जो manage कर रहे हैं dependencies, अगर ये compromise हो जाएंगे तो it could lead to a significant impact. On such attack that can be performed against dependency manager is dependency confusion, which will be discussed in more detail in the next task. Sure. What do we call a dependency that we have created ourselves and are responsible for maintaining? Internal dependency, of course. Uh, internal dependency. I think so. Yeah, okay, we are back to strict 2. Okay, task 2 then. Okay. Uh, Theory of a dependency confusion. Dependency confusion is a vulnerability that can exist if our organization uses its internal dependency that are managed through a dependency manager, such as JFrog, Artifactory. In short, a race condition can be created by an attacker that could lead to a malicious dependency being used instead of internal one. In this task, we will look into the theory of the dependency confusion vulnerability before practically exploiting one in the next task. Awesome, awesome. अच्छा जी, background. Dependency confusion was discovered by Alice Birson in 2021. You can click on the link. It is a Medium link and you can follow along. We will just move forward. The issue stems from how internal dependency are managed. Let's take a look at a simple example in the Python. Pip install numpy. What actually happens in the background when we run this command? When we run this command, pip will connect to external PyPy repository to look for a package called numpy. Find the latest version, install it. In the past, there have been some interesting ways this package could be compromised through a supply chain attack. Typo squatting. An attacker hosts a package called numpy, hoping that a developer will mistype the name and install their malicious package. Very clever. Source injection. An attacker contributes to the package for a new feature through a pull request, but also embeds a vulnerability in the code that could be used to compromise the application that make use of package. Okay. Domain expiry. Sometimes the developers of package may forget to renew the domain where their email is being hosted. If this happens, an attacker can buy the expired domain, allowing them full control over email, which could be used to reset the password of a package maintainer to gain full control over the package. This is a common risk for legacy packages on these external repositories. So for example, अगर आपका कोई email है, for example zahir at someemail.com, और उस email से आपने जो है वो पैकेज मेंटेन किया हुआ है, और कुछ देर बाद वो आपने डोमेन मेंटेन नहीं की, डोमेन आपकी एक्सपायर हो गया, और कोई मलिशियस यूज जो है उसी डोमेन को यूज़ करते हुए आपके नाम के एक ईमेल जनरेट करेगा और वहाँ से पासवर्ड रीसेट करके पैकेज को मेंटेन कर सकता है. डैट मीन वो पैकेज के अंदर मलिशियस कोड ऐड कर सकता है. इट्स अ लॉन्ग वे बट दिस कुड हैपन. ओके, तो 3 चीज़ें हमने पढ़ी हैं: टाइपोस, स्क्वाटिंग और सोर्स इंजेक्शन एंड डोमेन एक्सपायरी. ओके, आगे चलते हैं. There are several other supply chain attack methods, but all of them target dependency or its maintainers directly. If we wanted to use pip to install an internal package, we followed the example on Stack Overflow. Like all good developers do, our build step would look like this: pip install numpy extra index URL http our internal pypyserver.com. The extra index URL arguments tell pip that an additional pypy server should be inspected for the package. But what if the numpy exists in both internal repo and external public facing repo? How does pip know which package to install? Well, it's simple. It will collect the package from all available repos, compare the version numbers, and then install the package with the highest version number. You should start to see the problem here. Yeah, of course. Staging dependency confusion attack. Okay, we're gonna stage it, huh? All an attacker really needs to stage an internal dependency attack is the name of one of your internal dependencies. While this might seem like a challenge, it happens more frequently than you would expect. Developers often ask questions on public forums such as Stack Overflow, but do not abstract sensitive information such as the names of the library being used, some of which could be internal dependencies. Some compile application like Node.js will often disclose internal dependency names in the package.json file, which is usually exposed in the application itself. Once an attacker learns the name of an internal dependency, they can attempt to host a package with a similar name or on one of the external package repos, but with a higher version number. This will force any system that attempts to build the application, install the dependency to get confused between the internal and external package. And if the external one is chosen, the attacker's dependency confusion attack will succeed. The full attack is shown in the diagram below. ये थोड़ी सी diagram देखते हैं. अच्छा, पहले ये है कि अटैकर लर्न्स नेम ऑफ द इंटरनल पैकेज, वो एप्लीकेशन से लर्न कर लेगा. दूसरा, ये अटैकर अपलोड्स हायर वर्जन ऑफ द पैकेज. फॉर एग्जांपल 1.2 यूज हो रहा है तो हम 1.3 वर्जन जो है अपलोड कर देंगे अपने से बना के, उसके अंदर मलिशियस चीजें डाल के, राइट. ये पब्लिक डिपेंडेंसी मैनेजर है. बिल्ड सर्वर पुल्स पैकेज फ्रॉम एक्सटर्नल रिपो, ये है. बिल्ड सर्वर पुल्स पैकेज फ्रॉम द इंटरनल रिपो, ठीक है. हमारे वाला वर्जन क्योंकि ज्यादा बड़ा है, attacker's version is higher than sent to build agent, ठीक है. Malicious code is introduced in the pipeline, okay, and then the code is deployed to serve the users. यहाँ पे considerations हैं. There are a couple of things that should be kept in mind. Since we only know the name of the internal package, not the actual source of the package, if we perform a dependency confusion attack, the build process of the pipeline will most likely fail at a later step since the actual package was not installed. Of course, our external version number must be higher than the version number of internal package for the confusion to work in our favor. However, this is easy since we can simply have a package with the version number 9000, since most packages have major version number lower than 10. Of course, dependency confusion can affect any type of package such as Python pip packages, JavaScript npm packages, and Ruby gem packages. We will demonstrate the attack through Python for simplicity. तो डिपेंडेंसी कन्फ्यूजन का अटैक किसी भी पैकेज मैनेजर के साथ हो सकता है. अगर वो पिप है या npm है या जेम है या आई थिंक न्यूगेट पैकेज है, उसके साथ भी हो सकता है. लेट्स लुक एट द practically performing a dependency confusion attack in the nest task. Sure. What is the name of a common supply chain attack that relies on user mistyping the name of the package that they wish to install? ये हमने already पढ़ा है, typo squatting. Dependency confusion relies on a race condition of what of a package? Race condition can be created by attacker directly to malicious dependency. Confusion relies on a race condition of what of a package? Dependency of a package. I don't know, but let's see. No. Race condition of what of a package? This is very confusion. Maybe it is version of a package. Yes. We are at task 7, practical exploitation of dependency confusion. Let's see how we can use it. Let me start the machine first. Okay. It will take 2 minutes to start it. It's okay. Terminate the machine from task 4. Start the machine attached to this task to perform the dependency confusion. Access says if your attack box is no longer active, you will have to redeploy it, and we will have to simulate the external PyPy package repository since uploading malicious packages is against PyPy's terms of service. To ensure that you can manage this repo and the application, we use the following command to add an entry to your etc host file. मशीन अभी आई नहीं है, जैसे मशीन आती है तो इसका आई थिंक आईपी एड्रेस भी चेंज हो जाएगा. इन द मीन वाइल ये मेरी मशीन है. लेट मी ओपन अप terminal, make it a little bit bigger, and in just 7 seconds we'll have this IP address here. So see, IP address is also changed. I'll copy it and put it here, sudo bash -c. Okay. We have done this environment, explained the machine simulates a build environment that has the following internal dependency manager, PyPy, build server, Docker compose. The build environment will rebuild an API application every 5 minutes. Once you have given the machine a couple of minutes to start, you can verify that the API is working by following URL. Okay, let's see if it is working or not. Failed to connect. Connection refused. I think it's still booting up. So after few minutes, it will be available. Okay, let's move on. We'll check it again. Okay. You should see the API respond with the dataset. If you don't get a response, wait another 5 minutes and then try again. We'll wait for 5 minutes and then we'll try again. Yeah, okay. We'll be back in 5 minutes. So we are back. Our message is accepted. As you can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's move on. You should see the API respond with the dataset. If you do not get a response, wait another 5 minutes and then try again. Dependency disclosure. The developer of the application has posted a question on a public forum. Okay, upload package to internal PyPy server. Hi all, how would I upload a pip package to our internal PyPy server? I know I would use the following to upload it externally, but what should I change? Twine upload distribute data dbconnect -0.0.2 .tar.gz. Is there a flag or something that I can add? In this post, the developer seems to have disclosed the name of the internal package, data dbconnect. This is all we need to get started on our dependency confusion attack. Okay. Remote code execution in the installation step. Okay. To stage a dependency confusion attack, we will need to develop and build a malicious package that will execute code once installed. Since we only know the name of the package and don't have access to the source code, the application will most likely fail once it tries to run a package. So our safest bet is to get remote code execution earlier in the process. Hence, we want remote code execution once the package installation complete. This is probably a good place to explain how pip package or build from Python code. If you want to explore this process in more depth, have a look at the tutorial like this. You can click on it and follow along the tutorial if you want. We'll just move forward. Here we will give a quick overview. The most basic pip package requires the following structure: package name and package underscore name, then the / underscore init underscore .py, main.py and setup.py. Okay. Package name, this is the name of the package that we are creating. In our case, it will be data dbconnect underscore init underscore .py. Each pip package requires an init file that tells Python that there are files here that should be included in the build. In our case, we will keep this empty. Okay. Main.py, the main file that will execute when the package is used. we'll create a very simple main file. Okay, setup.py. This is the file that contains the build and installation instructions. When developing pip package, you can use setup.py and setup.cfg or pyproject.toml. However, since our goal is to remote code execution, setup.py will be used since it is the simplest for this goal. Okay. Recreate this folder structure for your malicious package and add the following code to main.py. Okay. Folder structure. Def main hello name is equal to main and main. This is simply filler code to ensure that the package does contain some code for the build. The more important part is setup.py code. Let's take a look at what a normal setup.py file would look like. Recreate this folder structure for a malicious package. अच्छा, तो हमने ये फोल्डर स्ट्रक्चर क्रिएट करना है, तो सबसे पहले है पैकेज नेम. So for example, let's see, make tire. What is the package name? In our case is DB connect. Okay, let's go inside DB connect. There is no file inside, so let's create another one. Package name again. Tire. Okay, created it. And then we'll have init.py. So there is a command we can pass with make dir to create it as a file. So set file mode as chmod rwx. Let me install and see if the mousepad install. If not, then I will install it. So it is installed. Mousepad. This is the file we need to create. I will just save it without anything here and close this one. Yes, we have the file here, and then we need to create a main py file, the mousepad, then the file name. We'll put this code into this file, and I'll save the file and close it. And then we have setup.py file. Okay, so in order to do that, setup.py file, copy pad setup.py. We'll copy paste the code here, but let's see first what we have inside. Let's take a look at what a normal setup.py file would look like. From setup tools, import find underscore package. From setup tools, import setup version v 0.0.1, but they explain it is 0.0.2. It should be 0.0.3. Okay, name dpconnect URL http github.com labs data connect. Download URL is this one. Author is China Screen. Author email is this one. Package find package include package data true MID description. Okay. In order to inject code, we need to ensure that the package executes code once it is installed. Fortunately, setup tools, the tooling we use for building the package, has a built-in feature that allows us to hook in post-installation step. This is usually used for legitimate purposes, such as creating shortcuts to binaries once they are installed. However, combining this with Python's OS library, we can leverage it to gain remote code execution. Update your setup.py file with the following. Okay. So, oh wow. So we change it. We have included setup tools, command.install, install OS and sys. Now, post installation command is this one, hello world from installation. And then we are trying to connect to attacker's IP address on 8080. And then we are setting it up like this. Command class is install port post installed. And let's take a look at the adjustment that we will made. Okay, wait a moment. I will copy all of this. From here and paste it in my add here. I still need to change the attacker IP address. We'll change it. It is, I think, 10.10.146.141 and save. There are still adjustment that we need to do. Let's take a look at the adjustment that we made. Finally, firstly, we imported the install library from the setup tools and the OS library, as you can see from here, OS and sys. We also updated the version of our package to ensure that we win the dependency confusion rate. So we went for the greatest version number, which is 9000. Next, we introduce a new function that will work as a post-installation hook to run a reverse shell for us. Remember to add your attacker's IP address or VPN IP. We already added the attacker IP address here. So it is post-install command install, then run self install.run self, and then hello world from the installer. This proves our injection works, and this is the shell that we are including. Lastly, we hook the post installation process in our setup configuration like this, install post configuration. Now that we have created the package, it is time to build it and upload it to the external py repo. We can use the following command to build our package: python 3 setup.py as dist, and then we will use this one to upload. Okay. So before we move forward, let's do that. I will close it and I will run this command. Okay. So it created all the things that we needed to have, as you can see in dist. Once built, our pip package will be available under the dist folder and can be uploaded to the PyPy repo using Twine. Okay. Let's use this command to upload it. This is Twine upload dist data connect -9000.0.2.tor.gz, and repository URL is http external dot py dash server dot loc 8080. So let me run this command and let's see what happens here. Uh, Enter the password to unlock your login keyring. What does that mean? Not get unlocked when you logged in your computer. So I cancelled it. Username is nothing. Did you enter it correctly? They are saying leave it empty, right? You're asked to enter, just leave them empty. You can also safely ignore the error and warning message as long as the output shows that the package uploaded 100%. I will cancel it. Uh, does it say that the package is uploaded or not? Uh, entry point. Okay, I just press enter and it uploaded and everything worked just fine as you can see here. Okay, we are good, we are good. Repo, okay. Just a reminder again that we are simulating an external PyPy repo to not break their terms of service. If this were a real attack, the package would be uploaded to PyPy's main repo, pypy.org. Let's start a listener from our shell, nclvp. So let's do that. But I will create another one and put our listener here. All right. We can test the code execution of our package by installing it directly ourselves. Package.install. Okay, I'll just copy paste it because it's a long command to write. So I will just paste here to install it. Did we get anything here? No, nothing. You should see the print line in the output of the installation command. See the pip freezes when you get a reverse shell connection. Actually, I did not get a reverse shell connection. I did not. Okay, we'll make a mistake. I think we did not put the right IP address. Let's see what is our IP address here. We put this one 10.10.146.141. If that was the right IP address, yes, it is the right IP address here. And then we have CSCD as well. I don't think so. We are doing anything in CICD. We should be able to. Let me run it again. Maybe it will work. Yeah, I did not get any connection here. If this works, restart your listener, wait for about 5 minutes. You should magically get a callback from build server once it tries to rebuild the Docker container and install our malicious package, explaining what is happening in the background. Okay, we'll continue. So how is this actually happening? Let's take a dive into the vulnerable line in the Docker file. Run pip install data DB Connect, no cache, dir, trusted dash host, internal dot pipe dash server.com, and an extra index URL is external URL. Knowing that this is an internal package, the developer team added an additional PyPy repo for pip through the extra index URL argument. However, this does not force pip to download the package from that location. Rather, it is just another location where it can look for the package. Pip will therefore download the package from internal.pypy server.com legitimate package and external.pypy-server.loc local our malicious package, and compared to version, since our version is higher, it will install our package instead. This is where the name dependency confusion comes from. Okay. Protecting internal dependencies is a massive security endeavor since we have to create, maintain, and host these dependencies ourselves. The security project is much larger than the than of external dependencies. The following defense strategies should be considered for all internal dependencies. Sure, we'll see that, but let's see why we are not able to get target IP address is this one, right? Just a moment. Attacker IP address we already put in there. Everything should just work fine. I'm not sure where we went wrong, but let's see. Okay, let's continue, and then we'll debug a little bit, and I'll give you the result offline. The internal dependency should be actively maintained. This will ensure that the vulnerabilities in this dependency do not affect multiple applications and services. The hosting infrastructure of internal dependency should be secured. The following Microsoft white paper provides the following three key focus areas. Reference: one private feed, not multiple. This contributes to protecting against dependency confusion attack. With our Python example, we would then use dash dash index dash URL argument instead of extra index dash URL. Indicate that the package must be collected from specified index. Protect your package using controlled scopes. By controlling the scope of the dependency, it will ensure the dependencies are logged to the application that requires them. Utilize client-side verification feature controls such as subsource integrity or version locking will ensure that applications and services will detect when malicious code is introduced into a dependency and refuse to execute it. Yes, as an additional defense measure against dependency confusion attacks, the name of internal dependencies can be registered on external package managers without the source code to claim the name. This will prevent an attacker from registering a similar named package. Okay. As an additional defense against the dependency confusion attack, the name of internal dependency can be registered on external package manager without the source code to claim the name. This will prevent an attacker from registering a similar named package. Okay, so they are saying that even on the external, just registered the dependency name, so nobody can upload the malicious code, any package manager. What is the name of attack that can be launched to create a race condition between internal and external dependency? It's a confusion attack. I just want to copy paste it. Then dependency confusion attack. Here we have it. And now, what is the flag value that is stored in the root directory on the Docker container where you get remote code execution? We did not get remote code execution. Let me try it again and come back to you guys. So I found the issue. I did not put the IP address right. it should be 146 instead of the other IP address that I mentioned. So I put the right IP address here, and now I'm gonna redo the same steps that we done before, which is to upload the package. Again, I'll just cancel it and cancel it again. Enter, and the package is uploaded. Error during upload. Retry with the verbose option from the more detail. What happened? So our command is not working. So we can do one thing. We can use skip command. Skip existing and then enter. Let's see, will it work or not? I'll cancel it. Just enter the user, cancel it. Just enter the password. Already exist. Uploading is done. Okay. Now we already listening to the code, and let's install it. Yeah. Did we get now? Okay. Let me remove it, and then we're gonna install it again. Okay. Pip remove. There is no remove command. Okay, uninstall then. Install. And then the package itself. So that means we just need to give the package here. I'll say yes, uninstall it. Okay. And now let's try to install it again. But we did not get cache. Okay, install the collector package. Database successful. Install the package itself. Okay, just a moment. Mousepad main.py. In which file we mentioned the version number? Let's set up maybe. Yeah, so let's create version number 3. Okay, and then I will save it, and then now let's try to upload this one. But before that, oh yeah, we did not set up it before, so let's create the setup again. Now since we increase the version number, so we need to put 3 here instead of 2. So I'll put 3. Cancel, enter, cancel, enter. It is uploaded. Now I need to install it, and hopefully this time I'll be able to get the remote code execution. Why it is installing 9.2, which is not great. Okay, mousepad. .py. Let's move back the version to 2. Save. Everything else is good. I will save it. Now it is saved. Let's repackage the package. Removing and everything under it, creating the tar file. Yeah, they have done it. Let me upload it. Skip this thing. Cancel it. I will cancel it. Skipping because it is about to be already exist. It should not be skipped. Basically, I just need to remove from this one. Yeah, we are able to get it. Yes. Awesome. So we are able to get the connection here. So what I need here is, what is the flag value that is stored in the root directory? Okay. ls cd root ls catch flag.txt. Okay, so we are able to complete this task, guys. Congratulations, we have done this. It took some working around, but we were able to do it. So congratulations. Conclusion. In this room, we discuss the security controls and misconfigurations commonly found with the dependency management. This is by no means an exhaustive list of what should be considered for the security of dependencies. However, to summarize, we should be considering the following. Be aware of dependencies you use in your applications and systems. Also be aware that these dependencies may have dependencies which will grow the list of dependencies you will need to keep tabs on. So dependency could have dependencies. Make sure to always use the latest version of dependencies, both internal and external dependencies, more often than not. These updates to the dependencies are not to introduce new features, but to fix existing issues and bugs. It is not just the dependencies themselves that should be considered for security, but also how we configure and use our dependency managers, especially for internal dependencies, and dependency management systems should be included in the attack surface of the application or system we are developing. So congratulations, guys. We have completed this room. Once we come back, we'll start the next room, which is SAT. And if you like the video, please give it a thumbs up. If you haven't subscribed, please subscribe. Let us build a Desi community on this channel. So we are targeting 1000 users by August 2024. So help us achieve this target, and I will see you in the next video. See you. Bye.